All right, question number 13. We want to find the domain again. And 13, we have f of x equals 8 plus, and then we have a fraction 2 divided by x squared. So just like the previous example we did, anytime you have a fraction with a variable in the bottom, we have to set the denominator equal to 0 to find our domain. All right, so we will have a restriction. I'm going to start out with D, domain, whatever's on the bottom, so it's going to be x squared. Okay, notice we have this plus 8, the 2 on top. Those do not affect dividing by 0. So whatever's on the bottom, it cannot be equal to 0 because we can't divide by 0. And then we solve for x. So the way we solve, we have to get rid of this square. You get rid of a square by taking the square root of both sides. So you have to square root the x squared and square root 0. From here, we would get domain, square root, square cancel each other out. Bring down the x. X cannot be equal to square root of 0 is 0 because 0 times 0 is 0. So here's your domain. Again, in interval notation, we would write this as negative infinity up to 0 union 0 to infinity. So again, remember that comes from this number line scenario. I would always do the number line, and that'll help you kind of see what's going on. 0's in the middle, we're removing that point. So we have the left side of 0 and the right side of 0. So that's kind of how this notation comes about. And they want us to type it in interval notation. That's why it's important to know that method. Negative infinity to 0, union 0 to infinity. Okay, number 14, we want to find the domain of this function. F of x, x plus 2 in the numerator, and then in the denominator we have 7 minus x. 7 minus x. Okay, same principle. We're going to take the denominator, set it not equal to 0. So starting with my domain, I'm going to say 7 minus x cannot be equal to 0. Okay, so I'm going to move the 7 over by subtracting 7 from both sides. I know to subtract 7 because it's positive. Don't let that minus x throw you off. Then we will get negative x cannot be equal to negative 7, and we cannot leave our denominator negative. So, our variable negative, not our denominator. So we need to divide by -1, or you can say multiply both sides by -1. So I'm going to go ahead and say divide by -1 on both sides, and that will leave me with a positive x cannot be equal to negative divided by negative is a positive 7. So your domain in this case is x cannot be equal to 7. So again, using a number line to kind of help you see how to put that in interval notation. Negative infinity, positive infinity. This time I'll put my number 7 here, and that point is being removed. So it splits it in two parts. The right side of 7 to infinity, and then the left side of 7 to negative infinity. Remember your union. You have to put both pieces together. Okay, so I'm going to input that. Negative infinity up to 7. And then union 7 to positive infinity.